Hello and welcome back. This is the fifth in our series of exam preps for the AP Computer Science A test. Going through this book. Okay, we're on chapter 7, writing classes. Now this one, I'll forewarn you, is a long one. Writing classes is really critical to software engineering, and there's a lot of material in here, probably a lot of things that are new, so we're going to take our time, heads up, get a comfortable chair, and listen up. So what is a class all about, first of all? I remember in one of the earlier videos I said I'm going to kind of just loosely talk about objects and classes, not really pay too much attention to what they mean, kind of use them interchangeably. Well, that's not going to be true in this lecture. They're going to be very different. But what is a class? So in the old days, we had what's called procedural programming. You just wrote programs, step, 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 step. You had variables, just like we've talked about before in other lectures with data types and so forth. The problem is, when your software gets to be really big, I mean hundreds of thousands, millions of lines long, think code for the space shuttle or something like that, it is really, really complicated. I mean, imagine if you had some variable name somewhere in millions of lines of code. Where is that defined? Good luck. Who's setting it? Who's changing it? What are they changing it to? Good luck. What if you have some junior guy, it's his first day on the job, and he writes a line of code that says something like, name is equal to, I don't know, onion. Because he thought that was what it was supposed to be. And it's really supposed to be a person's name. Okay, is anything in the code gonna, prevent him from doing that? Nope, that'll be fine. And so 500,000 lines later in some other part of the program, this onion will pop up and everybody will be going, what in the heck is going on? And so programs just got really unwieldy and huge. And so somebody scratched their head and said, well, this isn't gonna do. So what they came up with is a way of grouping together information in the code so that it's logical and you could make sense of it. And what they do is they combine behavior and data. In fact, I'm going to keep referring to this book a lot because there's specific terms the test wants you to take, some of which are widely used and some of which seem to be specific to your test. So I'm going to use their words. Well, we'll come to it. Data and behavior, that's what we'll go with right now. So the idea is, you instead of having a name like this, you're gonna have think of it as a box. A box. And in this box, here's your data, here's your behavior. And everything about this box relates to itself. So let's call this box shape. And we'll use this shape as an example throughout so we stay consistent. So data, well, it's information about a shape. Okay, well, what kind of information might we have? We might have, size, we might have color, we might have position. Okay? Well, what kind of behavior? What do you do with a shape? Well, you might draw it, you might hide it, you might move it, right? I'll put parentheses here. This is not Java yet. This is parentheses just to show these are behaviors. So you have essentially variables, data variables, and you have what will ultimately become methods. They're called methods when we define what these are. Okay? The point I want to get here early on is that all of this stuff relates to a shape. And so if you have millions of lines of code and they're doing something with a shape and you're like, oh my gosh, what's going on with shape? You don't have to look through it all. You can go directly to where shape is defined, and there it all is. It'll tell you, here's what we know about a shape, here's what you can do to a shape. Okay, so it's nice and clear, it's contained. This is what's called object-oriented programming. So what's an object? Well, first we have to define some things. We're going to define 3 terms: object, class, and reference. Okay, sounds like a lot of terms, but that's what we're going to do. Let's start in the middle. let's start with class. This is a class, okay? A class is, think of it like a blueprint. It defines what the class is and does. It's what it has and what it does. Well, it has this data and it does these things, okay? And this is like, you think of a blueprint for a house. How many blueprints do you have for the house? One. So there's one class, okay? And in fact, when you write this in Java, you would write a shape.java file, and you would talk about the shape class, okay? And in fact, when you compile it, this produces, the Java compiler produces shape.class. Now you don't run or even look at these class files. Those are binary and the Java engine knows how to run those, right? But you would write these Java files that correspond to the class, and it will get compiled into the runnable binary shape.class, okay? So this is like the blueprint, right? Now, so then what's an object? Well, an object is a particular instance of a class. What's an instance? Okay, well again, think of the blueprint. I've got a blueprint of a house, and I'm a builder, so I'm gonna build, here's the blueprint, right? And on the blueprint is some picture of a house, right? Well, I'm gonna come along and I'm gonna build a house from the blueprint. Great, now I'm gonna go down the street, I'm gonna build another one. Phenomenal, I'm making money. I'm gonna build a couple more. Okay, now I've got 4 houses. Now those houses are different. They're different physical houses, but they're all exactly from the same blueprint. They're identical floor plans and all that. This is the class. These are the objects, instances. Okay, each one of these is an object. You can think of it like, making a copy. You're only gonna have, like, over here, one shape class, but you can have any number of shape objects. You could have 10 of them, you could have 1,000,000 of them, doesn't matter. Each time you can, we'll see in a little while how to create an object from a class in the code. But every time you do, it's gonna use this as your template, your blueprint. It'll say, okay, you want one of these? Boom, there's another one. But every time you make one, it's different. It's different, okay? Even though it's the same class, they're different objects. All right, now, so that's an object. Is that somewhat clear? All right. So what's a reference? A reference is, remember how we can assign a variable a name, like a string name, int age, something like that. All right, I can have a variable in my code. Let's say I have a house class. House, my house. Okay, that's a crappy age, there we go. My house is equal to, and then we'll see how to define it later. So my house is actually, think of it as a pointer, okay? So what this is gonna do when we define all this, it'll ultimately create one of these guys, okay? And it's gonna stick it in memory somewhere. That's where the actual object lives. But you gotta be able to use it. So it's gonna create a pointer to that house. This is my house right there. That pointer is called a reference. This is the reference to this, okay? So I can have house, other house, equal, and it creates, say, this house. 2 different houses, 2 different references. Now if I come down here and I say, my house is equal to other house, now I've done something weird. I've not changed this object. What I've done is change this pointer so that now it points to this one. I've changed the reference, not the object or the class. Okay, so the class is the template, the blueprint. The house is the actual instance, the actual thing that got created in memory, right? And the reference is the thing that connects the variable to the actual object in memory. That's a lot. Is that sinking in? good? It's a reference kind of a flaky thing. Let's see if we can explain the reference a little better. You have to have a way of pointing to a chunk of memory. Let's look at it this way. In memory, I'll come over here. In memory, you just got this big chunk of RAM over here. Can you see that in the video? Okay, so let's say in memory, it's got a house here. It's got a house here, and a house here, and here it maybe has something else, like, Fred. All of memory is not houses. It's got other stuff that the program's doing. So as I created houses, I got one here, one here, one here. Okay? I need a way of accessing this in memory. This label here, when I say my house is equal to da 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 da, I'm creating a reference, a pointer to this one, my house. So my house is pointing to this one. The pointer is the reference. Okay? So when I come down here and say my house is equal to other house, this my house is just a variable, right? What I've done is I've said, okay, forget this pointer. I want this to point to that house now. I've changed the reference. I haven't touched the object, and I certainly didn't modify the class. If you guys can imagine a little bit, you can only change the class in code and then compile it. When the program's running, you can't change the class. It's fixed. You can create a bunch of objects though. And so in this case, I didn't change the object. I changed what my house is pointing to, the reference to which object it is. Does that help a little bit? Good. All right. Some concepts, we're barely scratching the surface here, so these are some important concepts. Not easy stuff, but this is like at the heart and soul of object-oriented programming. Details, I'll give you some soft skills here for a minute. How do we label our classes? Okay, classes have a convention in Java. When you give your class a name, they almost always start with a capital letter. Variables, like I said, my house, right? My house, that's a variable. The variable's camel case, meaning the first is a lowercase letter and any additional words are capital letters, right? Classes are the other way. Everything's capitalized. So the first name, or the first letter is capital. Now that is a convention. You could call your class with a lowercase letter. Compiler will say, okay. Most Java programmers will look at you like you don't know your stuff, because that's not how it's done. So start your class with a capital letter. Don't start them with a number or some other weird character. It has to be a letter. Also in Java, it's required that every class have its own file. So if you have, dog, cat, lizard classes, those are 3 different files. Okay? All right. Let's see. Make sure I'm hitting all the terms. Your book calls out source code. So this is the source code. Hopefully you know that, but that's the Java file is the source code. Okay. All right. Let's dive into the mechanics of the class itself. Now I said this is just sort of cheap and dirty to describe how it is, and I said this would become methods. So let's make these methods. Actually, let's start with the data because that's a little easier. You can simply say, just like we did before, int size equals 0, int position equals 0. How about Boolean is drawn equals false, something like that. Okay, just regular variables. Typically in a class, make this bigger, we put the word private in front of these variables. If I can spell it. Now, there's a reason we do that. This technically is called data hiding. But we put this private in there. What that word means is that you can use all of this stuff in the rest of your class, all of these variables, all of this data, no problem, just like normal. But outside the class, if I'm in another class or another part of the program, I cannot directly talk about shape's position. If I try to use the position of a shape just like that, you remember when we did the math, we had like math.abs, right? Just to call a method in the math library. If I tried shape.pos, it'd blow up, so you can't do that. It's private, okay? I mean, you could make it public, very bad idea. If you wanted it public, you just say public here instead of private. Don't do that. The reason it's private is because if you want to allow people to change or access one of these variables, you know, you're going to have some of these methods. Some of them are called mutators, some of them are called accessors. Big labels, simple meanings. A mutator is something that's going to change this data. An accessor just returns it. Okay, now you're thinking, okay, wait a minute. If all I'm going to do is allow somebody to maybe change the position or access the position, why go through all the drama of mutators and accessors? And why not just say make this public and go have fun and go get what you want? Why go through all that? Here's the answer. Maybe it's as simple as just getting and setting position today, right? And let's say you have a huge program, millions of lines of code, and later on, somebody has a new requirement that when you change position, you have to do some other important stuff. Make up your own example here, but let's just say when you change the position, other things have to happen. We have already got hundreds of uses of this all over creation in this massive program, or worse, other people's programs you don't even know about, right? And so you can't do the other stuff without breaking everyone. Okay, now if you have a mutator function, so when you set position, and maybe the first time you do it, it's just trivial. It just says, okay, pos is equal to whatever they give you. If you have to do more stuff, you can add that more stuff to your mutator method in the class. So everybody else that's used to calling your set position mutator will keep doing it. They don't know or care anything's changed. Only you do. And so you don't have to, you know, hide from a bunch of angry programmers looking for you. So that's why we go through all this drama, even though a lot of these, what are called getters and setters sometimes, or mutators and accessors, are very simple. Let's look at one. So that's how you define data. How do you define this? Let's just focus on position since we started that example. Okay, we'd start with public. Void int get pos. Okay, this is exactly a simple getter. And just again, by convention, you often just say the word get, lowercase, capital, the name of the variable you're getting. To, everybody does. Okay, notice there's no parameters in this method. This one's just retrieving something. It returns, here's where your data type goes. It returns an int. And it's public, not private, because we want people outside this class to be able to see it. This is the public area that we want people to use. In this case, we're just returning pos. Right? That's all we're doing. Okay, and then to illustrate my point, let's say, why don't we just say make pos public and they can get it directly? Why go through all this drama? Okay, here's why. Okay, so here's the return boss. My boss comes up and says, I want to know every single time we are accessing pos. So I'm going to come in here and say, okay, logger.log get pos or something. Doesn't matter, I'm making this up. We're doing some other work here, okay? Okay, so here I've added this little logging thing every time somebody calls get pos. Okay, now if thousands of other people are already using this, they don't have to change anything. It still works. Okay. Otherwise, I have to go everywhere this is used and add this extra code everywhere it's used. Nah, I quit. I don't want to do that. Okay, so this is why we use these accessors. Same thing for the setters, the mutators. Okay, so does the accessor make sense? Do you see what it's doing here? Define a method, public, data type, the name of the function, the name of the method, and then a block of code. This I didn't mention this. This return is important. A method should return something. Okay, even if it's nothing, and we'll see that in a minute. This word return says, okay, I'm going to return this variable pos. The data type of whatever you return has to match the data type that the method says it's going to return. If you returned a string here, the compiler would say, no, you can't do that. You promised to return an int, so you must return some kind of int. Now this is dumb. You could do this. That would compile and it would run. It'd be wrong. You know, this is always return 3 regardless of where the position is, but it's a valid code, right? 3 is an integer, has to return an int. All good, right? Okay, so that's what they call a logic error. There's technically nothing wrong with it, but when you run it, it obviously does the wrong thing. Okay, so let's look at a mutator. Let's clean this up. Mutator, a public void set pos int p pos is equal to p. Okay. Let's unpack this one. Here we're mutating, changing. Mutate means change, or sometimes they call these setters. Okay. Just like the other method, we have the data with the word public, the data type returned. We're not returning anything in this case, so we use this void word here. It means I'm not returning anything because we're setting a value. We don't expect something back. This pattern of set and then the name of the variable. And this time there's a parameter. We're passing in the new position that we want. Okay? And then here we're just saying, okay, pos is equal to p. We're just setting pos is equal to p. That's it. Okay. Does that make sense? Okay, this is how you write a mutator. Now, we can get fancier. Maybe we, for whatever reason, don't want this to be public. We want this to be private. And you're thinking, why would we want that? Maybe we want something like this. Public void move. So we're moving the shape, right? So the first thing we do actually, no, let's do this. Okay? So think of it a game. You got a spaceship or something, you want to move it. Okay, so how does that work? You're going to take it off the screen, change its position in memory or in its class, and then redraw it in its new position, right? Okay, so that's the actual behavior we want. We don't want people randomly setting positions, bouncing the spaceship all over the place. We want it to move in some logical way. And this can get much fancier too, and we'll play with that. So in this case, I wanted to show what we've done here. We've made the setter private, because we don't want people just randomly setting the ship position to the shape anywhere. We've made the move method public, because inside the move method, it's going to do the extra work of hiding the shape, changing the position, and redrawing the shape, which is actually the behavior we want, right? I'm doing this to demonstrate. You obviously could do all that in set pause, but technically this is probably a little better because it's closer to what it means, move. Now, the other thing I want to point out here is this curious use of this. This is in your book. This, what in the world is this? Okay, do you remember when I had all the houses and I said each one is an object, right? Okay, when this thing runs, this is the blueprint, but when it runs, it's gonna run on one of these objects. Let's say it's this one that's running. And so when this basically means this one. I mean, you might have like H1, H2, and H3, meaning H1, H2, and H3 to represent the references to each of these house objects, right? Well, this means, I don't want to confuse anybody, I mean this one, the one I'm in right now. So if I'm dealing with H2 and I say H2 dot move 13, whatever that means, okay? So it's dealing with this one right here. This is the one we're dealing with. And so when it comes in here, I want this one to hide. I want this one to set the position, and I want this one to show. Okay? That's what this means. There are many cases where this technically isn't necessary. In fact, you could get rid of this in all of these cases, and this would work just fine. However, it's always, and there's some cases though that you do need it. It's always clearer to have it, because then when somebody's reading your program, they're not confused. Especially when you're mixing things up. Let's say you have two shapes that are working together, and for whatever reason, you pass a reference in to move because somehow a move interacts with another shape. I don't know why, but let's pretend it does. You might confuse. Let's do that. Let's say, comma, shape. So this is the background. Okay, there's some shape in the background. Okay, so in this case, we're working with two shapes: the current one and this background. I don't know what we're doing with the background. Maybe we're moving the background in an opposite direction. Okay, so there might be some code in here that dealt with background. So you don't want to confuse this with background. Does that make sense? Okay, so this word disambiguates, makes it clear exactly what you mean. It's always a good practice. All right, let me take a break real quick to make sure that I'm covering everything I'm supposed to cover in here. Oh yeah, your book has, this is one of those cases where it's sort of created terminology I've never heard before, but we'll go with it because they're the ones giving the tests. They have, not to confuse you further, because we keep using this word object, what I've explained here about object, class, and reference, that's actually how it works. They actually have this thing called an object class and a driver class. Now it actually makes sense what they're talking about here, but these terms are not widely used outside of the AP test. Okay, what an object class is in their world is the class like I've just explained it. So shape. Okay, that's an object class. It's what a thing has or does. Its data and its behavior, right? The methods and the variables, the instance variables, right? Clear? Okay. The driver class is the thing that uses the object classes. So if I have, I don't know, what would this be? Class, paint. And in class paint, I'm using a bunch of shapes, right? Class paint would be considered the driver. Class shape would be the object. Now the reason, okay, I mean, first of all, is that kind of clear? That this is sort of the driver because it's composing or combining all of these object classes. I just call them classes, all the classes. I just want you to know this term because it will be on the test. Okay, object class and driver class. Now in reality, the reason it doesn't matter is because in real life, these things are all mixed up anyway. Paint might actually be a class by itself. using other classes. Classes uses other classes all the time. So the distinction between one or the other is kind of hard to pin down. But for the sake of your test score, let's pretend that's important and talk about object classes and drivers classes. All right. I think we're ready for, yeah, we are, for instantiations. All right, let's go back to shape. Public class shape. All right, that's how you create a class. There are such things as private classes, don't worry about that right now. Public class shape means anybody can create a shape. So how do you actually build one? Remember I said it's a blueprint, right? How do you actually build one? Well, there's a special method that you put in your class that allows you to build one of these guys. And it looks like this. Public shape. Okay? Now you remember, actually I'm going to move this. Remember we had int position starts off with 0. We had int size equal 0, and we had boolean is drawn false. Okay. Now this is obviously a stupid shape because a real one would have all kinds of data points or other information. I'm just keeping it simple. So here's your public shape. Now this thing right here is actually, I won't use that because that's actually a programming symbol. This thing is called a constructor. Because when your driver class calls it, it's going to create a shape, an instance, right? It's going to create an instance, like you're going to build a house from the blueprint. Okay, so that is a constructor because it constructs a shape from the shape class. Nice? Okay. Now, very good. And of course you have stuff in here if you have to set up some things. Now in our silly, stupid example here, you can notice one problem with this class. It has no position, no size, and it's not drawn. Now that's okay. Maybe you want to create a shape and manipulate it a little bit and then, splash it on the screen. But what if you don't? What if you want to have something come out right at the beginning? Well, there is something called overloading. Overloading is where you have the same method with two different lists of arguments. They call this a signature. Okay, if I can have public shape int p int s and boolean, I'll just say d. Okay, and then the implementation of this method would simply be this pause equal to p, this size is equal to s, this is drawn is equal to d. Okay, so I can create a shape passing nothing and it's just going to get these default values. In this case, I have written another constructor where you pass in all the values as you build the shape and it assigns them accordingly. Okay, and you can have as many of these as possible. I mean, obviously a real class might be very complicated and you might have several constructors. That's called overloading because they're both the same name. Now you notice what's missing. 10 points if you figure it out. What's different about a constructor and a normal method? There's one thing that's not there. The audience doesn't know. I'll give you a hint. It goes right here. A data type for the return value. Remember, a normal method would have public or private, normally public, some data type, and even if there is no data type, you'd say void, public int, public string, public boolean, public void, the name of the method, maybe some parameters, and then the code, right? Right. This one doesn't have anything here. Is that an error? No. It's not necessary because what does a constructor construct? A shape. And so we know what it's going to make. In fact, the lack of that data type and the fact that this name is exactly the same as the class name, I forgot to mention that, that's important. This name has to be exactly the same as the class name. We already know what it's going to do and we already know what it's going to produce. So we don't need a return type here. That's what makes a constructor special. All right, hopefully that's clear. All right, now I think we can show how to use it. We're actually getting toward the end here, so that's good. So how would you use this? This is how we start to pull things together. So I'm over here in my driver class using the shape, and I might say something like shape box is equal to new shape. Shape circle equal new shape 115 true. Okay, so I've created two shapes here, a box and a circle. I've created two references to objects that were created from the shape class, but these are all in my driver class. It's confusing, isn't it? Anyway, we've created these two new shape objects. We use this constructor here and this one for circle. They're just like we had multiple houses. Now we got two shapes, two references, one to box, one to circle. Okay? And in this case, I've defined all my parameters. In this case, I just give me the defaults. All right, I think I've only got one or two more concepts to cover. Is that clear? That's how you use them. You could do that in a loop, by the way. You can create hundreds, thousands, millions of objects. Millions might be a problem. Your Java machine will ultimately run out of memory and blow up, but you can create many, many, many of these. We talked about constructors, we talked about instance variables or fields. These are the instance variables, or sometimes called fields. We've talked about return types, talked about that. Okay, a couple of terms. Your book talks about preconditions and postconditions. These are comments, honestly. They're not. There are languages that actually can force you to do it in code, but Java isn't one of them. A precondition is a comment where, and this really isn't specific to a class, it can be anything, but if I have some method say public double div me, some sort of division. I have double A and double B. Again, I'm following my own bad example. These variables should all have meaningful names, but since this is a contrived example, I'm just using A and B, so I don't have to write too much. Okay. Now over here, let's say I'm going to return A divided by B. Okay. A precondition is simply this. You put a comment and say, describes what it is. It's A by B. B cannot be 0. That's a precondition. That B cannot be 0. Okay. Now, if you're writing very important production code, like the world's going to end, somebody's going to die, or your company's going to blow up, if something happens, you could actually write an if statement right in here at the very first line. Since if B is equal to 0, do some error and don't do the rest of the method, right? So that's also considered a precondition. But in terms of your book, I think it says it's a comment. But it's essentially, either way, it's a check to make sure some condition is true before you actually go in and do the meat and potatoes of your method. Likewise, a post, so this is a precondition. The audience is yawning. It's almost over. Okay, post condition. Same thing. I don't actually have a great example, but it would go here at the end. So, you know, maybe something like result must be less than 1 or something. Again, that's made that up. Whatever the requirement is to say that this successfully ended. And likewise, you could make it a real requirement with an if statement that says, yeah, if the result of A divided by B is greater than 1, do something bad or tell somebody, raise the alarm, whatever you got to do. Okay, so that's precondition at the checks at the beginning of the method to make sure everything's kosher that came in. Post condition is at the end to make sure everything we're about to return fits whatever your business need is. Okay. We talked about accessor methods. We talked about mutator methods. Don't you feel educated now? Planning. They have planning as a key word here in the book. I'm not sure why. I think it's just encouraging you to think carefully about how you design your classes, kind of like what we did here. Before you write any actual code, just make a list of here's the data we need to store in this class. Here's the actions that go with that. Just think about how you want to organize that before you go to all the work of starting to write code. We've talked about composition, which is basically using, making new objects and using them in other objects. I'll reiterate one thing, just one thing to make it clear. To use something in a class, you use the dot. So if you remember our shape, we'll say shape S is equal to new shape. Okay? And so if I want to move, I'd say S dot move. 3. Okay? So that dot, just like we had, math dot at ABS, the S dot move. Okay? Now if I try to do something with the private, if I say something like S dot pause is equal to 5, I'll get an error because the pause is private. I can't set that directly. Okay, we covered that already, just making sure. Right, I think I've got one more important thing to cover. I know everybody's tired because this is a long but really, really critical thing. Crap, they define another term, an aggregate class. Okay, we had the object class, that's the shape. We had the driver class that uses the shape. Now they're defining an aggregate class. It's a class that has other classes in it, where these data fields in the class are actually references to other classes. Well, that's kind of obvious, right? You might have shape, you're going to draw it, maybe you have a class for screen or something, right? Inside the shape, maybe. So anyway, they've given these things names. I think as long as you understand that it's called an aggregate class and that you can use, a class can have other classes in it, you can use other classes within it, then you'll understand the reference. And of course they have examples in the book which I highly encourage you to look at. Okay, we talked about references, great, we're done with that. Talked about this keyword, and I think we're down to this last, yes, we're down, this is the last one. Everybody take a shot of adrenaline. This is the last concept. This is one of the most important chapters in the book. So this is good to. All right. The last thing we're going to talk about is this word static. I'm not talking about a bad radio reception. Let's change it up here. Let's say class, public class, game. Okay. And in game, we have int high score is equal It starts off with 0, right? And we're gonna make this, I think, let's see, we wanna make that private like usual. Yes, we do. Private. Okay. And down here we have something like public void set high score int HS. Okay. And I'm not going to use the braces because it's just one line. We're going to say this. Actually, let's not say this. We'll just say high score equal to HS. Okay? So far, so good, right? Does that look pretty familiar and understandable based on what we've learned? All right. There's a serious problem with this class. Very, very serious problem. You're all tired, so I'll just tell you what it is. As we have the driver class making games for many players, it's going to be creating, an object for each one. So here's game, there's game, everywhere game, right? Boom, 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 boom. There's 4 games. Okay? Each one of them has their own high score. So if I set the high score, let's say the high score here is 100. This guy only got 50. This guy rocks, he's got 500. Okay? And this guy only got 2. Which one is the high score? This one? All right. It is, but the way I've written it here, there is no high score. Each one will be the high score for its own object, because that's all it knows. Everything's in this box, right? So how do we fix that? How do we have something that goes across all objects? That's what static does. Okay, sorry if that's too small. I've got private static int high score. We'll fix this one in a minute. But what this does is basically say, oh, we're going to make a special object over here called game. And in here we're going to have high score. And it's going to be used by all of them. Okay? So it's going to be shared. Static means it's around all the time. So now all of them will be 500. Right? Because they're sharing the same instance variable. It's not, normally it's one per class, right? They each kind of have their own little private world. Think of this as a shared world that goes across the entire multiverse of objects. How'd you like that? I made that up in the fly. Okay, but that's what that does. That's what static does. And that's perfect for high score, because we want, no matter how many games there are, we want all of them to have the same high score across all the games. All right. Now, this is broken now. We can't set high score because this is only in, remember this object? It's only dealing with like one of these, this one. We want it to set the shared high score because this is now shared with static. Actually, they should have called that shared. That would have been a better keyword, but they call it static. We want to set the static one. Well, don't worry. All you got to do static. Yay, fixed. Okay. This is called a static instance member or a static data member. This is a static method. They go together. So now this method is actually over here. It's going to operate. Okay. Now this method though cannot use, let's say you have other data members over here. You can't use them in here because it doesn't know about it. This is its own private little object. It doesn't know about this one and this one and this one and this one. It just knows about the shared stuff. Okay? Do we need to say anything else about static? Oh, yeah. How do we use it? So if in my driver class, I'm going to have game G1 is equal to new game. Okay, and I don't have a constructor in here. Imagine I have one. Okay, game G2 is equal to new game. I can say G2 set high score 300. Actually, it'd be cool, a better implementation of this would be to check what you pass in, and if this is higher than high score, then set it. Otherwise, no. Let's do that real quick. If HS is greater than high score, high score is equal to HS, else do nothing. Why would you set it to a lower value, right? Anyway, see, I can say game G2 is equal to set high score, dot set high score, and that works just fine. But there's something else that you can do. Remember I said this is shared across all this stuff, and that you don't need any of the per game information to make these shared things work? We can do it with the same thing we did with math. When we were using absolute value for math, we said math, which is a class, dot some method. Those are static methods. They don't depend on anything except itself. So I can say game dot set high score 300. That's valid because it goes with the game class. It's shared amongst all of them. Doesn't matter which game, right? So these two would both work, but this is actually the preferred way. It just emphasizes. So sometimes you can use this static business, just like math and string and some of these library objects, to have libraries of things that don't depend on anything else. They're self-contained. They do just a simple function. They're not connected to any particular object. Handy utilities. They're often implemented as static methods on a class. Okay, quick review. Make sure I have not left out anything critical. I don't think I did. Talked about static methods. Yep. Talked about static variables. Yep. And that is it. Let's see. Aggregate class, reference static variable. Everybody tired? That's it. Review. Make sure you read and understand everything in here. Do your exercises. Thank you.